Have you ever stood near a compactor roller and felt the vibration travel through your body? The ground trembles, nearby machines react, and one question comes to mind. How can a single machine generate such power? Where does this vibration come from? And how does it penetrate deep into the soil? At first glance, a compactor roller looks simple. It moves back and forth to compress the ground. But in reality, it performs one of the most critical tasks on any construction site. It creates the foundation on which everything else depends. In its natural state, soil contains countless air pockets between particles of sand, gravel, and earth. If these voids remain, the ground will eventually settle. That settlement leads to cracks in asphalt, shifting foundations, and expensive long-term damage. The roller eliminates these risks before they appear. It transforms unstable material into a dense, reliable base capable of supporting heavy loads for decades. For many years, people believed compaction depended mostly on weight. The heavier the machine, the better the result. Weight does matter, but only at the surface. Static pressure compresses the top layer, while deeper layers remain loose. Everything may look solid above, yet weaknesses can exist underneath. That is why roads sometimes fail even after heavy equipment has passed over them. To truly restructure the soil, pressure alone is not enough. Energy must travel downward. That energy comes from controlled vibration. When vibration is combined with mass, the process changes completely. Waves move through the soil, forcing particles to shift and reorganize into a tighter structure. Air escapes, density increases, and load-bearing capacity improves significantly. This vibration is carefully regulated. Frequency and amplitude are adjusted according to soil type and layer thickness. The goal is precision, not chaos. The source of this vibration is hidden inside the steel drum. At its center lies an eccentric shaft fitted with unbalanced weight positioned off-axis. When a hydraulic motor spins this shaft, centrifugal force is created. Thousands of vibrations per minute are transmitted directly into the ground. The drum becomes more than a cylinder of steel. It becomes a precision compaction instrument. Modern rollers rely on hydrostatic transmission. There are no traditional gear shifts. A diesel engine powers a hydraulic system with variable displacement pumps. One circuit controls movement, while another powers vibration. By regulating oil flow, the operator controls both speed and direction with remarkable precision. This ensures smooth, stable motion and consistent compaction quality. One unusual feature is the absence of a traditional accelerator pedal. Effective compaction requires constant speed. Sudden acceleration or slowing disrupts energy distribution in the soil. The operator sets the pace using the drive lever, and the machine maintains it automatically. Steering uses a central articulation joint that allows the machine to bend in the middle. This keeps the drum fully in contact with the ground during turns. Operating such a machine exposes the operator to continuous vibration. Over time, this can affect the spine and joints, reduce concentration, and increase fatigue. That is why vibration isolation is essential. Rubber mounts and isolation systems separate the drum from the chassis. The cabin seat are designed as protected zones. Vibrations remain focused in the soil, not in the operator's body. Stopping a machine that weighs several tons requires careful engineering. Safety relies on redundancy. Braking is achieved through hydrostatic transmission. When the operator returns the lever to neutral, hydraulic flow decreases and the motors slow the machine gradually. Some models include additional hydraulic disc brakes for extra security. The parking brake is spring-applied and remains engaged by default. Only sufficient hydraulic pressure can release it. Heat management is another critical factor. The engine operates under constant load. Hydraulic oil circulates under pressure, and braking components generate heat. Radiators and heat exchangers maintain stable temperatures for both engine and hydraulic circuits. The drum itself also helps dissipate heat. Despite their similar appearance, rollers are not universal. Smooth drum rollers are for asphalt, pad foot for cohesive soils, and pneumatic tires for surface finishing. Choosing the wrong type results in poor compaction and strain on the machine. Modern rollers are specialized and expensive. A compactor roller is far more than a vehicle. It balances efficiency, durability, and human safety while shaping the foundation beneath our roads and buildings.